Now I want us to apply a Wronskian. This is one of the applications of a Wronskian. Then they give a question like this. Say verify that the functions y1, y2 are linearly independent solutions to the given equation and find the general solution. If I'm given a differential equation like this, y double derivative, the second derivative of y plus 5, the first derivative of y plus 6y equals to 0, and I told them that y1 and y2 are solutions to this equation. They want me to show that this y1 and y2 are solutions to this equation, and then I show that they are linearly independent. First of all, what do we do? To show that if y1 is a solution to this equation, if I put in y1 into this equation, I should get a 0, because it's a solution. And then if y2 is a solution again, therefore, if I put in y2 into this solution, I should get a 0. Therefore, I will just need to first get the first derivative of y1, say for y1, which equals to e power 3x, e to power 2x like this. Then this first derivative is what? It's going to be 2 e power 2x. Then the second derivative is what? It's going to be 4 e power 2x. Now, if I put this equation of y1 into my differential equation, if I get a 0, therefore I will have shown that's the solution to this differential equation. I'm saying that if I put in that where there is y double derivative, I put that this second derivative. If I put there 4 e power 2x, then minus 5, then the first derivative is 2 into 2 e power 2x, and then plus 6. My y is e power 2x. I should get something like a 0. Here I have 4 e power 2x minus 10 e power 2x plus 6 e power 2x, and therefore minus is going to be 0. Then I just conclude that therefore this y1 is a solution to this equation. Therefore y1 is a solution to this differential equation. Similarly, I do the same for y2. If I have my y2 and my y2 is e power 3x, therefore my first derivative of y2 is going to be 3 e power 3x. Then my second derivative of y2 is going to be as 9 e power 3x. Then if I substitute these equations into my general equation, I will have 9 e power 3x minus 5 into the second derivative is 3 e power 3x, and then my plus 6 into y, my y is e power 3x. If I get a 0, therefore this will show me that also y2 is a solution to this equation. This is 9 e power 3x minus, this is going to be 15 e power 3x plus 6 e power 3x. If I add 9 minus 15 plus 6 is the same as 0. Therefore, I'll conclude that y2 is a solution to a differential equation, because if I substitute in the first derivative and second derivative into this equation, I still get a 0 as my solution. Now, here I'm showing that it is just their solutions. Now I want to check whether they are linearly independent solutions. To check for linear independence, we must apply a Wronskian. Then if I say a Wronskian, my Wronskian is going to be the same as having y1. My y1 is e power 2x, and then my y2 is going to be e power 3x. Then if I differentiate it first time, I want to have e power 2 e power 2x and 3 e power 3x. Then determinant just measure that one minus measure that one. I have 3 times this one will have 3 e power, I add the powers, going to be 5x minus 2 times this one going to be 2 e power 5x, which is the same as having e power 5x, and this e power 5x is not 0. Therefore, I will conclude hence the solution is y1 and y2 are linearly independent because y1 and y2, our Wronskian is not equal to 0. Now, for the part of finding general solution, I'll just need to use my conditions to show that I just use these conditions I've been given to find the C1 and C2. Now just remember, also at the end of our solution, our general solution y is going to be equal to C1 y1 plus C2 y2. Where I have my y is going to be equal to C1 I don't know, but I know what y1, which is e power 2x, plus C2 y2 is e power 3x. Now, in order for me to get the general solution, this is the general solution to this. This is the general solution to this differential equation. But since I'm given these two conditions, I'm able to get the value of C1 and the value of C2 from this equation. Now, let me put off this so as to just use these conditions so as to get the C1 and C2. I'll put off this and I leave out the conditions. I'm saying that if my general solution is this one, if my general solution is y equals C1, y1 is e power 2x, and plus C2 e power 3x, and they are saying that y at 0 is negative 1. If x is 0, my y is not. Therefore, I have negative 1 equals to C1 e power 0 plus C2 e power 0. But e power 0 is 1. Therefore, I have negative 1 equals C1 plus C2. That way. But they're saying now the first derivative at y, the first derivative at 0 is negative 4. Then if I differentiate this y, the first derivative is going to be 2c1 e power 2x plus 3c2 e power 3x. Then if I put there 0, when x is 0, my is going to be negative 4. I have negative 4 equal to, where there is x I put there 0, I have 2c1 because e power 0 is 1 plus 3c2 because e power 0 is going to be 1. I have these two equations. I have equation 1 and equation 2. Now I solve equation 1 and 2 simultaneously so as to get C1 and C2. I use any formula, and I may even press the calculator and I get the answers. But now I can use any formula. I can use elimination. I eliminate C1 by putting a C2, by putting a 2 on the, I just multiply a 2 through this equation 2. I'm saying that I may use elimination by multiplying a C2. I have this equation is negative 1 equal to C1 plus C2, and then negative 4 equals to 2C1 plus 3C2. Using elimination, I multiply 2 times the first equation like this. I have now two equations in this format. Negative 2 equal to 2C1 plus 2C2. Then negative 4 equal to 2C1 plus 3C2. Then if I decide to subtract these two equations, I have negative 2 minus 4. I have positive 2 equal to negative 2 minus 2 is going to be 0. Then 2 minus 3, I have negative C2. Therefore, C2 is negative 2. And then I can easily get C1 from equation 1. My C1 is going to be equal to C2, negative 1 minus C2 is negative 1 minus C2, which is negative, minus negative 2, which is negative 1 minus is going to become a positive. I'll just have a 1. Therefore, my C1 is 1. Therefore, I can write my solution as y equals, instead of writing C1, I just write 1, which is the same as having e power 2x plus C2, which is negative 2 e power 3x. And then this will be my solution to that differential equation. since I have two linear independent solutions, y1 and y2. And let this be a take home. Do it, and we shall see the solution afterwards. Let me give you just a take home, and you do it, and then we shall see the solution. If I give you an equation like this is a take home, xy double derivative minus x plus 2 double derivative plus 2y equaling to 0, and then I give you my equations as 2 equaling to e power x and y2 equals to x squared plus 2x plus 2, sorry, and then I give you my conditions to be y1 equaling to 0 and y at 1 equaling to 1. I want you to show me that these two solutions given to you are linearly independent, and hence you find the general solution with C1 and C2 not equaling to 0. Thank you for listening. Subscribe and comment. For any questions, put in the comment section. I will be answering with time. Thank you.